we'll call it the cracks or the separations between, this is a panel door. These are panels that are connected together. They look warmer, and that is the temperature difference because they're so thin. They have the same emissivity because they have the same surface treatment, the same crack. So now we can perform some analysis of this image to find out some more information. One of those is if we wanted to check temperatures in certain spots, we could put spots in, we could drag them around. So there, and when I put this in, you can see we have a spot here, spot 1's 101, and it shows here now under our temperature list that it's 101. You can do a spot location. It gives you the actual pixel location. So 114x and 240y. So you can see as I go to the right, x increases, and it's y, so 00 is the top left corner. And then our full resolution of 463 by 347 is the bottom right. So you can do those kind of things with it. Okay. We can also do some other measurements. So just on some of our measurements here, we can do those hot and cold spots. And now that we have calibrated the emissivity, those hot and cold spots are going to be, they're going to be accurate. I can show where they're at if I want. Hot spot markers, cold spot markers. You can also measure sizes. So if we're looking at damage on something, this door doesn't really have damage or anything like that, but we can do different sizes. So I can enable things like area. I could even turn off all these and just do area. If I don't want those, it gives me my dimensions in square feet, and we can go in our image and also change measurements. Now the measurement setting for this image is in feet. Okay, and then some of the other things we're able to do is we can adjust things like scales and that kind of thing. So here, this is, we can move our scale left to right. You see as I drag this box at the bottom, it's changing the top and bottom. I can drag it lower. Now what it's saying is essentially there's nothing below 96.4 degrees. But if I bring it up, you can see anything. So now below 98 starts to drop out, turns black. If I really want to look in detail at those hotspot areas, I can kind of shrink my scale to just look at those to really delve in and look deeper into these areas between the metal panels. But I can select my range. Okay. I can change my palette if I want to look at different things. So what it says from image, this was the default palette that was used, but sometimes different color palettes will show different things. So this one, cool, is designed to highlight cool areas. Black hot is kind of a reversed. Usually an image is white is hot. And so we can kind of look at those, and sometimes you'll see different flaws or different items with different palettes. We've got the fusion modes that we talked about. So if I want to do thermal only now, remember we did this one with MSX on. Oftentimes we'll drop out MSX when we're looking at features, when we want to focus on the thermal features. Is we switch it back so that we're only looking at the thermal items, because the MSX, the visible image, allows us to see surface, but often we're going to use thermography to be trying to find subsurface flaws and things like that. There's ways to change how the colors are distributed, so you can try to highlight different things. There's enhancement, histogram equalization is the default, but you can do all kinds of different ones. So here, linear, it just shows how the scale lines up. Isotherms are used to, we can say above, so anything in this case right here, above a certain temperature is going to be red, and then below is that. So This can be used if you've got, one area you want to see anything that's getting above a certain temperature, if you want to really dial it in, what shows up that way. So those are isotherms. Below would be anything below or cold. There are sometimes alarms for if you're doing humidity, which is a type of below alarm. So humidity typically causes cold, or dew points as well. Insulation is typically used for things like buildings, and you can kind of tweak those. They'll set indications if they see things and like this insulation one, again, used for buildings, indoor temp, outdoor temp. It can kind of figure out if there's area where there's like where a building might be lacking insulation. So you can see the alarms thing here came up that wasn't there before. So these can be used if you want to try to do different kinds of analysis and that kind of thing on your images. In order to see. Sometimes if you have, especially like a composite image, it's sometimes easier to see with by changing the color scale or changing the color palette or different things like that. I have lots of examples in here, and one you'll do in class, looks something like this. And so you can, this panel you'll work with in class and kind of try to find some images that are similar, but this is the same panel at different periods. So there compared to this, which, if I adjust and drop out certain colors, I can really start to highlight the damage kind of in the top right corner. I can even turn that, make it turn white or more red. Or go back to kind of, this is our standard iron palette. So you can see in the iron palette, it's not as obvious. Drop out some of the lower temps. So you can see the damage a little bit right here, but in that rainbow type color palette, you can kind of see it a little bit better possibly, where you can see the damage, starting to turn white right up in this right-hand area. So those are different tools that are available. Here we go. Here's a good, you can see the honeycomb at the given adjustments. Whereas if the temperature is too broad, you can't really see the honeycomb as much. If I put it into, again, back in the default iron, really doesn't show up much. You don't see that honeycomb at all. And this is the MSX mode, but I'll put it in thermal. There you go. You can see the honeycomb a little bit, but not nearly as defined as if I go into, some of these other color palettes like this one here. We can really start to see the honeycomb start to come out. So sometimes looking at images in different ways, adjusting the temperature range and the color, the scale, and all that allows us to kind of pull out some details that maybe aren't available. And this one's had reflected temperature and emissivity was already found on it and programmed in.